tell us what's so fundamental about these things that we learned at the end of last semester? What's the fundamental theorem of calculus telling us? Anybody? Don't look it up. Think about what's so fundamental. There used to not be a course called calculus.
Oh, wait.
Remember? Okay, there's not a course
It's
called
that the
calculus.
sums and the other thing is related.
The linear approximation.
Sorry.
Linear approximation is very fundamental, but it's not the fundamental theorem of calculus.
Wait.
What was so profound that Euler and, I'm sorry, not Euler, that Leibniz and Newton found?
That you could reverse the group.
Yes, that they're, so what's fundamental? Is that these sums that they were finding,
No.
okay? Where they were looking at areas and volumes. As they were finding sums of areas and volumes, remember this notation, alright, so Leibniz was summing up lengths times widths. Y'all did that for a few days, not as many days as if I was your AP Calculus AP teacher, but you did it for a few days, okay? Does that make sense to you, what I just wrote on the board? F of x is like a y, so those are lengths times widths. Alright, so this would give me the area of a rectangle. Would you agree with that?
Yes.
Alright, and dx is how wide the rectangles are, alright? And Leibniz was using the, y'all did that a lot, okay? Where you added up 3 or 4 rectangles or whatever to estimate the area under the curve. Leibniz was just doing this, and Newton. This is really Leibniz's notation. I don't know, maybe Newton was writing that. We fell on Leibniz's and Newton gets most of the credit. But anyway, they were actually adding up rectangles, finding area and volume. And so the fundamental theorem of calculus is that you could really look at it like this, and instead of doing all of that summation, you could just take the antiderivative. Okay? So I'm going to erase that plus c for a minute and give it, do y'all know what I mean by limits of integration? We're going to go from like 0 to 5.
Yes.
Okay? So that would give us displacement. That would give me f of x from A to B. Or in other words, f of B minus f of A. Which until I showed you, well, let me pause there. So what is so profound about that is that area, volume, distance, all those things in terms of displacement, actually you could take the antiderivatives of them, and if you knew the rate at which something was moving, you could take the antiderivative and find out what happened during that time frame. Okay, like whether the rate of flow of something into a tank, if you take the integral, what's so profound is they found out you could just take the antiderivative instead if it's possible to take the antiderivative. So they found the incredible link between integral calculus and differential calculus, which it wasn't called that back then. It was called rates of change, which were slopes and stuff, and area and volume and distance. And they found, and now that we know it, and it's kind of funny that they didn't put those two together, because I know that the derivative of volume would be dv dt. It would tell me the rate at which the volume, so it sort of makes sense to me now that I know that I could go backwards. But it took until the late 1600s for them to realize that. Then they started calling it calculus. I don't know at what point, and they started putting it all together in one book, okay? Because probably soon after Newton and Leibniz, word got out that integrals could be solved possibly by antiderivatives. So every integral that's not true. Most integrals that I look at, I can actually take the antiderivative and solve it. But until they made that aha moment, like, oh my gosh, I'm doing these pages of work, when I could have just taken the do you remember I used to do like x squared plus 3 and go on and on and on until one day I eventually added up an infinite amount of rectangles. And then class was almost over, so I don't know that I really made the point very well. But then if I took the antiderivative in like 13 seconds, I would get the same answer, okay? And they're like, oh my goodness, could this possibly be true? And we talked about if this is the velocity,
And I'm counting for dt means my seconds are changing, 1 second, 2 seconds, 3 seconds. From like 0 to 10 seconds, let's say. So this is my velocity graph, okay, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I don't know if I drew enough. But what we were doing was Riemann sums, finding the area under the, it's only area under the curve since it's all positive, but anyway, finding the area under the curve, okay, so I find an area. And what they realized is if I'm going at a volume of, I kind of showed it to you really with a constant value, if my volume is 50 feet per second, and I go for 10 seconds, again, it's sort of even hard to teach because it's so intuitive to us today, but it was so profound for them to realize all of this time they thought they were finding area under a curve, they could have just done it with an antiderivative. What's 50 feet per second for 10 seconds takes you back to 50 feet. I'm sorry, it doesn't take you back to 50 feet, it takes you to 500 feet. But the point I'm trying to make is it takes you to feet. So you go from a rate, feet per second, to a distance. Y'all see what I'm saying? And so this 500, where they thought they were finding the area under the curve, they was, wait a minute, I just found the distance. And what is velocity? The what of distance? Or position, it's the derivative of it. It's how fast you're moving through that distance. So that was the profound moment, is that when they thought they were finding area and volume, you could have just done it with an antiderivative, okay? Which makes a huge, huge difference in these things that are not geometrically shaped. All right, so the fundamental theorem of calculus is right here. And it tied derivatives to integrals. They used to call integrals antiderivatives. Integrals were summation tools, and they were doing all of that summation, finding all these tricks. Remember how we talked about what's better, left, right, or mid? All right, what's better, mid or trap? That may be a toss-up depending on the graph, but those are both really good, right? We talked about all sorts of different things where they were in the chase to find this. And then all of a sudden, Leibniz and Newton realized, wait a minute, I could just maybe take the antiderivative. And so that was what was so profound, okay? Rates of change, area, and volume. All right, then you probably didn't think a whole lot about this. Keep in mind, girls, this is displacement. I have to be really careful when I say distance, area, and volume. It's just the displacement. If I really want the area and volume, I've got to be careful, and we'll talk about that in our worksheets today. You probably didn't notice that f of b minus f of a until we did the average value formula, the AVT. Some people call it the mean value formula, mean value theorem for integrals, and there's a mean value theorem for derivatives. All right, so it was the thing I called mashed potatoes. There's some value. There's some y value. I don't think I did it very well, because if I did the mashed potatoes, then this part would, as I mash it down, would ooze over and fill in this part, okay? So whatever this area is, could also be described by this rectangular area over A to B, okay? So what do you think the average value is going to be if I did the integral from 0 to 2 pi of sine x dx? What would the average value would be 0, because what's the area enclosed there? Area is a loose term again. What's the displacement would be 0. All right, the AVT, our formula, which sometimes is called the mean value theorem for integrals, is 1 over b minus a times the integral from a to b of f prime of x dx. I use f prime a lot there. They use f, and then how do they go backwards? They make it a what? But I really like that to just still drive home, hopefully, the point of the fundamental theorem of calculus. Obviously, I don't walk in here after the new year of me racing through that. I didn't really race through it, but it's going through that, and thought that you would be able to answer that question. I reserved minutes and minutes and minutes, maybe all throughout the semester, to still drive it home. I'm not sure I got that even until I was a teacher, because nobody said it to me over and over again. You know, I shared with you, I didn't know the fundamental theorem of algebra, and I was a math teacher. I saw it in the textbook, in my algebra book, and I'm like, I don't know what that is, I better look it up. Fundamental theorem of algebra is if you have a polynomial with like x to the n power, x to the 5th power, it will have 5 zeros. Some of them might be imaginary, but there will be 5 things that make that 0, okay? Fundamental theorem of calculus is up there. Now, if I do this, and actually work this out, remember I get 1 over b minus a, and the answer to this is f of b minus f of a, and once again we see our friend what? What is that?
Our friend.
F of b minus f of a over b minus a? You're back to slope again. Do y'all see what I mean? Okay, so we're once again back to slope. It's all through this. All right, let's look, all right, let's look at problem number 1 together. Problem number 1, if f of 1 equals 12, and f prime is continuous, 1 to 4, we have f prime of x dx, we're told is equal to 17. We can't see f prime, we don't know what it is. By the fund of FTC1, by the first fundamental theorem of calculus. By the way, girls, FTC2, the second fundamental theorem of calculus is more about what Anna was starting to say, that they're inverses of each other. But we have to be careful. We did a really good worksheet on that, and we'll continue to look at it. But if you take the derivative of an integral, they basically wipe each other out, sort of, kind of. Do y'all kind of remember that? Where we walked over here to Barcelona and we came back with stuff in our suitcase. Okay?
On the water.
No, flew to Barcelona.
We should
Came
do
back
that
with
more.
Okay, so if I understand the FTC, that would take me back to displacement of the original. So remember how we did this worksheet, FTC 1 worksheet a while back, where y'all did really well on it. It becomes an algebra problem. They are crazy about these questions. There'll be tons of them in your exam this year, and we'll do a lot of practice problems. But it becomes an algebra problem to where you can really find what they want you to do, f of 4. So if I have f of 4 minus f of 1 is 12 equals 17. So sight unseen, I know f of 4 is 29. I can actually find f of anything if you give me f of 1 is 12. I can actually then start to graph this and talk about it and everything. Okay? All right, so that's a big, big deal. All right, try number 2. You can check your answer on the back. See if you got it right. You can volunteer to come up and work it if you feel comfortable doing that. So, not right now, but raise your hand if you volunteer to work it. I'm gonna let everybody else think about it some. get 4, the answer's 4. Anybody got 4 yet? Alright, let's work it. Okay, let's work it together and see. I think I'm right, but we'll see. Maybe I made a mistake. I think I even checked my answer then. Okay. Alright, you can distribute an integral symbol, okay? So I'm gonna distribute this 2 f of x from 2 to 5. Technically I should remember how I told you this symbol really comes and goes together, like those surround a math problem. I could have sine x sitting there and then I can integrate it and it would, those two things would have to appear. Alright, so, keeps changing back. Alright, so anyway, then I can say now I want the integral from 2 to 5 of 3 dx. And I know that equals 17. Is everybody with me so far? Alright, and it's very unusual to be able to distribute a math symbol, but remember it was a sigma, and we talked about all that before. I can also factor out a coefficient. And so I'm going to take out the 2 from f of x dx plus 2 to 5 of 3. In fact, let's go in and work this one. What's the antiderivative of 3? I can actually work this out. Sorry. I can actually work this out. What's the antiderivative of 3? 3x from 2 to 5. And now I've got a math problem and algebra problems here. This is 2 times what? What is the integral from 2 to 5 of f of x dx? Oh, I'm sorry, that's what we're looking for. Sorry. I was mixing it up with the first problem. All right, so I'm looking for this, 2 to 5. This is still my whole variable expression. This is going to be 15 minus 6. All right, so let me pause. Is everybody with me? I just distributed it. These will happen to you on the next test and probably the next test and practice problems. Don't try to do transformations. My first instinct was try to think of what would happen if I stretched and moved the graph. That's not what this is about. Probably would work, but it's very difficult, okay? Any questions so far? Are y'all okay? You get what I'm doing? All right. And so now I have 2 times the integral of f of x dx from 2 to 5. And it starts to collapse in a good way. That's 17 minus 8, 9, which is 8. And then what are you going to do to find the integral from 2 to 5? What's your last step? Divide by 2. And you get 4. Had a lot of 7s. So I don't know how you got 7 or if you want to ask a question. Is everybody okay now? Alright, so if you see something like this, from a to b of f of x dx, and then they give you or ask you for some more information, and they do something to it like 3 f of x plus 7, just be very literal. Just go through and start distributing and working it out with what you're given or what you're asked. All right? Okay, do 3, A and B. The answer to A is 5, so you'll know if you got that right. The answer to B is 6.5. A few people have stopped. Does anybody have 5? Did you get 5 and 6.5? Okay, so we'll work it together. Or tell me what you did. Somebody volunteered just to tell me what to write. So we're not moving around the small room. Anybody? How are we gonna get it? Or did you just do it intuitively?
Yeah.
Alright, so if it's a free response, I gotta show my work. Alright, so, I'm gonna show my work, plus I feel a whole lot better about what I've done if I actually work it out algebraically, okay? So, I'm gonna say I know that the integral from 0 to 6 could be formed by going 0 to 2 of f of x dx and continuing on from 2 to 6. And that should give me the integral from 0 to 6 as terms of displacement, right? If I go from so do y'all see how I'm being very literal about how I got there? Always use the numbers that they've been giving you. That's really key. All right, so I think we're looking for, what's 0 to 2? That's the region A, but what should I call that? 0 to 2 is right here. They told me that that area in that region was 1.5, but what do I need to call that in my algebra? Negative 1.5 because it's underneath. I've got to take care of, I know it's displacement. So I'm going to say this would be, if it goes underneath, the integral is actually negative. And this is what I'm looking for, 2 to 6 of f of x dx. And I know this was 3.5. So now I know algebraically that this would be 5 when I add that to the other side. Okay? Alright, and so then the absolute value. Hopefully on the absolute value you understand there's really not any need to do a whole lot of writing here. I can't even think of a way I would really want to do that. But if I do absolute value, and this is f of x, then this would flip up here, and I would instead keep a running total of negative 1.5 and, well, I did write this down. I don't really know. I wrote down 5 plus 1.5. Oh, because I already knew this was 5, and the negative 1.5 would pop up and be 1.5 for 6.5. I'm sure there's a way I could think to write it, but y'all understand that? Or y'all okay with that? Okay. All right, something just popped into my mind I wanted to talk about here just a bit that we'll get into more later on that you did a lot before Christmas. If this is f of x, and I'm integrating it, and I'm starting to talk about g of x. Suppose somebody tells you that. They go, hello, I integrated f of x and I got g of x. And what is f of x? It's g prime. That's applying the fundamental theorem of calculus. Doesn't it have to be? Are y'all okay with that? So if you integrated something and you got an answer, must have been its derivative. There's always a derivative, a slope, or rate sitting right there. That's g prime of x. So then immediately label this as g prime of x. And so now you know that your derivative of g is negative and positive and so on and so forth. You can find maxes and mins. You can find absolutes. You can test the endpoints. All of this stuff, the fundamental theorem of calculus enables you to do that stuff that's sort of foggy before that should become more clear. Okay? All right, let's go on. Is everybody okay? Go on to number 4. Read your graph carefully. It's just a little clue, a hint there. Also, I want you to do this. I'm sorry to interrupt you while you're thinking. Find the word estimate in there and underline it. Estimate and underline it. They really mean you're estimating. And only if it was multiple choice, only one answer choice would be feasible.
There's definitely there's like a way to guess. You just get the you have to find the error. So it's
Oh, yes, yes. Yeah, I said 6 months, yeah. So actually 200 minus.
Here's the answer. Did somebody already get it?
No.
Oh, I thought somebody said I did.
I got F of B minus 1,000. Okay, all of these boxes are what, 300? The area.
You did not get that?
I got 1350. So I probably just like.
Well, you're starting with 12,000.
Oh,
Let's say 7 boxes.
Oh, so you would probably get it.
Negative.
You're starting with 12,000.
I don't get it.
Hey girls, you're gonna do a lot better if you set up the relationship using the fundamental theorem of calculus, okay? So sounds like we need to work this one together. Sounds like it's a good thing I did this worksheet today, alright? How much is each box worth? Oh, nobody knows.
6.
300,
The area.
okay?
50 times.
You're right, they're 6 by 50, right? So each one of these little squares is 600, 300, alright? So each little square is 300, but I'm gonna set up something first. I want you to underline something else as you're following along with me. The graph on the right shows the rate of change. So what is the graph at the right? The rate of change of the quantity of water. So I'll call that W prime of T, alright? I've got the derivative. So I'm going to integrate W prime of T dt, and I'm going to integrate it from 0 or 1 to 30. Alright, y1 because they gave me that number and I need to use it, and y30 because they're asking me for that number, so I need to put that in there. Do y'all see why I chose 1 and 30? Alright, now by the fundamental theorem of calculus, what will that take me to? The rate at which the water is flowing for a certain amount of time will take me to the what? The amount of water. This will take me to WT from 1 to 30, or at least the displacement of it, right? We don't really know if somebody's draining the water while I'm trying to fill it up. Those are problems will come at us also. Girls, again, do you see how I'm being very literal about what I'm doing? I see the word rate. You're not there yet. You're getting there, okay? You see the word rate. You can integrate rate to get the original. Once again, the fundamental theorem of calculus is this is in liters per day, and what does dt mean? Per day, right? I mean by day. dt is I'm going by 6-day increments. So if we got liters per day for 30 days, won't I get the total amount of water? Liters per day times 30 days will give me a bunch of liters. Alright? Okay. Now to be very literal, I'm going to take the integral from 1 to 30 of w prime of t dt is equal to w of 30 minus w of 1, which is 12,000 liters. We started with 12,000 liters. And then the rate of change of quantity of it in the water tower in liters per day during the month of April. Alright, so what does this mean to us? That's why I have to teach this the way that I do, because the AP program's gonna make sure you understand what in the world you're doing, okay? What that means to me is that's a summation tool. Remember how Mr. Walters and I jokingly fight about is not an I can't take the antiderivative of that, so that means it's not an antiderivative necessarily. I gotta know what somebody really meant. Girls, if I could take the antiderivative, I could solve it that way. That was what Leibniz and Newton found. But what does that really mean? It's a running total, it's a summation tool, okay? And so if each one of these is 300, and I had you underline the word estimate, I got 1, why won't it go away? Did I insert it into my?
Press.
Press what?
Try pressing escape. Yeah. And then just go back into full screen. Like click on that. And then
It's just like really weirded out. Like I'm clicking on it. Notebook. What have I done?
try.
Is it down here? All right, so
You want me to try?
before, yeah, please.
I know.
This seems to be an image.
Yeah, that's really big. How was your break, Mrs. Larry?
It was really nice.
That's nice. It was good. I was in Spain. I just got back yesterday.
You were in Barcelona, were you?
No, I was in Snow. That's where my quad. Yeah. We saw our house there. So.
Were you there for
Yeah, for 3, because we left early. Yeah, we just got back yesterday.
So is there a specific day on Spain?
Yeah, we celebrate it like my dad's side is in Colombia, so they do like Santa Claus and stuff like this. But then in Spain, they also do gifts on the 6th. It's like the Halloween Magi, whatever. So we kind of do like double gifts. Yeah, it's right. Did you go to Memphis?
Wow. Yes.
I didn't, I went December 6th. But we stayed in the city and we just went skiing upstate. But other than that, I was here.
I hung out with a lot of people in Memphis. I went to all my mom's friends. When she was younger, there was like 10 women that she's known for like 30 years, and they were all in New York. So I went to a lunch.
Oh, how fun.
It was quite interesting.
That's so cool.
The only thing they wanted to talk about was college. So.
Are there daughters going, or children?
They all
going
have kids who are like graduating from college or in college. So, and like my mom has the youngest kids out of all of them. So they were all like trying to tell me about all these school questions like that. And I was like,
That's arousing. Yeah. There's like 30 of them. There's tons of my former students in New York. Tons. It's crazy. So I guess lots of people come to New York.
What even is
What in the
this?
world have I done? I don't know. I don't even know what I did. Maybe restore default course.
It's not like letting me quit.
Okay, let's just open, try, go to open.
I can just quit it, but then we'll probably have to restart.
Here, let me try this. That's gonna be my next one. Let me try this and just see if I can open another file. It sounds like I'm gonna have to quit it, doesn't
I
it?
don't know, it's being really weird.
Quit swimming. Did you try to quit it already?
No.
Try force quit?
Wait, scroll down. Cause is this? Scroll down, see if anything else is like unresponsive. Enforce quit? Oh, no.
Oh, sorry, I'm force quit.
Yeah.
Can you tell?
Okay, yeah, sure. Because I don't even know if that's part of. I don't know, that was really weird.
Okay. Notebook's just like, okay, I thought I usually had an icon for notebook. That's weird. I think it's usually down there. Maybe.
You can just press, like,
Should I try
yeah,
that?
because I tried to save it before.
Thank you.
It's all there.
I think we're good. Thank you. Okay, thank you, Anna. All right, we're back. So, I kind of lost my momentum there and whatever I clicked. So, they're going to make sure you really understand what you're doing. This right here actually finds displacement. Remember, they were trying to find area under the curve. And now I've also sort of like lost my graph. I moved it over somewhere. I don't know if I can get it all back. This would be easier just to draw it again.
Maybe you can undo, just like go all the way back.
I'm so scared to do anything with this right now.
Yeah, true. I understand.
Alright, so if you look at yours, when I counted the squares, I got like wait, it's aggravating.
Yeah.
Again, this will happen to you. I mean, not what just happened to me, hopefully, but this type of question you will see, okay? And so, if this is horrible drawing, I'm sorry. Anyway, each square was worth 6 times 50. You may not have thought to look at that before, but now you will, because I've made you think about what is going on. Just think it's 1 by 1. It might be something else. So this is 300. I can see 1, 2, 3, 4 full ones, okay? And then this one I sort of thought if I'm estimating might make 5. My drawing's not very good. I thought that might make 6, okay?
Wait, you did it with, okay, yeah.
But what does this do? I think this is another one if you look at your paper. Look at your paper. It looks like to me that if I count in the positives, I got 1, 2, 3, 4, 5, sort of 6 full squares if I made it a puzzle and put it together. And this part underneath looks like I should subtract off 1 square for displacement and get 5. Do y'all see what I mean? No? Yes? Y'all need to see what I mean because this is the day you're seeing this, okay? Anna?
How do you, will they like take points off if you like do a different estimate for the squares? Like,
If it's multiple choice, there'll be only one that is remotely feasible. If it's not multiple choice, they'll have to be a whole lot more clear about what you're doing. They won't leave you just out there estimating like crazy. But if you follow my lead, this is what they always mean. In fact, girls, this is what a lot of people in real life do. Because a lot of times they're projecting, they just want to estimate it. It's a really good estimate. They can go ahead and predict. They can probably price some things out and maybe come under their estimate. Maybe they would overestimate. All right, are y'all okay with this so far? All right, so I have 5 of these, and each one of them is worth 300. So I thought that this part right here would be 5 300s is equal to W of 30 minus 1,200. 12,000. And so then I added 12,000 and 1,500 to get the answer, which is 13,500. Always put your units of measure. Know that you've gone back to leader. Sorry that problem took so long. I really didn't want to lose my momentum there because it's you gotta understand what you're doing. It's an easy problem. A lot of these problems are really easy, but we're now only on number 4, which again is what I expected. But we gotta make sure we understand what's going on. Okay? Now let's go back to Anna's question. There'd only be one that's remotely feasible, but if you forgot to check and you thought they were 1 by 1, you would have subtracted like 5. And they probably have the answer choice, 11,995 or 12,005, I guess is what you would have got. You see there's sort of no mistakes you're prone to make, okay? Or you may have thought it was 6 by 1. You may have called the 6, but not the 50. All right, let's go. All right, get out your calculators and try number 5. All right, y'all need to kind of hurry. And this is the last one I'll let you do on your own, and then we're just going to start going through them together. Okay?
Yeah, tonight.
Or just go with Caitlin or, yeah, I think you have time, go get it. Because we'll need it in another time. What 2 words do you think I want you to underline?
Estimate and
Rate.
rate.
Very good. Ray, very, very good. Underline those 2 words. Yes? Great. Awesome. I'll write the answer up here. Okay.
They always have to do that when we come back from break. They like do everything. Oh. Okay.
Anybody have the answer yet?
Not yet.
Oh, so you can put it in there.
There's a relationship between, I think, the number that I just heard and the answer that is on the board. Emily, were you the one that said the -20 whatever? Okay. Hey girls, let's move on. I think what Emily has done, she can correct me if I'm wrong, is she saw the rate, which is -7e to the -0.3 t. Always write dt, and I'm thinking she integrated it from 0 to 10. All right, everybody pause. Pause. That's what I've said. It's not just an antiderivative, okay? If you punch that in, you should get -20 something.
Yes.
Okay, well then you need to type yours in again. Try it again, and I'll look at it if you can't get it. Emily, will you read me a few numbers of what you got?
-22.17.
Give me a lot more decimals.
0.17163.507.
Like this?
Yeah.
Okay. What is that? They'll ask you what that means. Remember that worksheet I did where I said explain the meaning of?
Total.
What is that? The running total? Okay, flesh that out. The interval for 10 what? 10 what?
That's like the degrees.
Yes. In 10 minutes, what's happening to my coffee?
It's getting colder.
Of course. Okay, it's cooling off. Alright? And guess what I want you to write on this side? That's the what if temperature, girls. That's the what if temperature. Read your problem. That's the what if temperature. What's the word they use? You're right, but what's the rate? What's the word they rate? Okay? Listen, please. Write down what you mean, okay? If you write that down on a sheet of paper, you're doing a rate in degrees Celsius per minute for 10 minutes. That's gonna give you, and girls, does that make sense? Negative? That's how many degrees your coffee cooled off. What am I gonna write on the other side? T of 10 minus T of 0. Do you see how I'm using the FTC? Write that stuff down. That's what I've done on every problem so far. Do y'all see what I mean? Are y'all okay with that?
Yeah.
Alright, it gives you displacement. Why am I writing T? I'm writing T for temperature, that's dt, the rate of temperature. Alright? So I want the temperature after 10 minutes. And what was the initial temperature, T of 0? 90. And so how are you gonna find T of 10? You get 67.828 degrees Celsius. Always give your units of measure. That make sense now?
Yeah.
Yes.
All right, Grace, did you get it okay now?
Yeah, I put in the minus sign instead of the
Okay, later on, girls, we'll revisit this problem and we'll do it by hand. To a degree. I would never want you to do this by hand with an answer like that. That means you just don't even bother. But there'll be some of these exponential and logarithmic integrals we'll need to take. All right, so stay with me on number 6. All right, on number 6, this is what I'm talking about. Water is pumped into a holding tank. Emma at a number 6 rate. Okay, she thinks she just guessed of what I wanted at a rate.
No, I.
All right, so I have 5 minus 5 e to the negative 0.12 t. Oh, I didn't mean guess. I meant like that you weren't reading the problem and you thought I meant it. Never mind. Good, thank you. Okay. Rate. What are we going to do with a rate? We're going to integrate it to go back to the original. Okay. What numbers are we going to use in our limits of integration?
0 and 60.
0 and 60. Thank you. Look what Grace caused. It says an hour later, but thank you so much. It says an hour later, but the units are in what? Minutes. You've got to notice that stuff. Very good, okay? Now, I would want you, by the way, that should actually have parentheses on it. This is a rate of water in the holding tank, so this would give me the water at 60 minus the water at 0. Do you see how you're going to do so much better on these problems if you write down what's happening literally? Y'all see, every time I'm writing, the integral is equal to the displacement. Every time. Okay? Emily, have you got this number for us?
258.364.
Equals W of 60, which is how much water is there 1 hour later. And we started with 1,000 liters. And let me check, our answer should be 1,258. Oh, something's wrong. That, is this negative 258? The answer is 741.636 liters.
Because it's coming out, not in.
Oh, thank you. Water's being pumped out of the holding tank in liters per minute, but it should, just a minute.
Wait, no,
It should still work.
Let's see.
Water is being pumped out because the cup of coffee was also cooling, so it came out negative. Has anybody else done this integral?
I also got
Maybe we should just make it negative.
If you subtract them, do you get the answer? 741.636. What's 1,000 minus 258.364?
771.635.
Okay. Why is this happening?
Maybe
If the holding tank, they could be wrong. I didn't check that. I'm just going by the answers in the worksheet I got. Holding tank contains 1,000 liters of water when the pump is started. How much water does it hold? 1 hour.
But it has to be
Yeah, the
negative
water's
because
pumped out of
it's
the
pumped
tank.
out.
Shouldn't the rate so you
I'm just
Yeah,
surprised
should
it
be.
doesn't come out negative because it didn't happen on the cup of coffee. Did it?
But like
Came out negative when you took the integral on the calculator, it came out.
It
was
came
a
out
negative
negative.
number, yeah.
But this one did.
This one didn't.
But the
That's
coffee one had like a negative in front of the rate.
Yeah.
But this one, the rate is positive. Or should be.
I think that's what's happening.
Oh.
On number 5, they said the temperature is changing at a rate, and as Sophia's noticed, it already has this -7 in the front of it. On number 6, water's being pumped out, and so you would expect it to be a negative. I don't think they've already built it into
But it's
this
5
problem.
minus 5e.
Yeah.
But it's to the negative and then it's like a fractional exponent.
So you did that whole thing.
No, because that would give you a positive because of that exponent.
So it's never gonna be greater than 0.
It's never gonna be less than 0.
Water's being pumped out of a holding tank.
Yeah.
Right.
What if it's pumped out of one tank into another?
I'm just
She's just trying to make it work.
This hasn't.
happened to me before, so let me think. What I usually do in this situation, because we see these problems all the time. The coffee, I didn't even think about it on 5 since it came out negative, I just took it.
Don't you have to?
Changing at a rate of -7. Grace?
Well, one thing I was thinking is, wouldn't you have to do 1,000 minus W of 60? It's coming out. I don't know.
Say it again?
1,000 minus W of 60.
No.
No, that was the other,
No.
that would make up one.
Like, that's how, like, the thingy goes. It goes like,
The
F
thingy.
B minus, like, you know, I don't know.
This looks like it's 2 space bars, you see? So what about it was in this? It just got like lighted out.
No, you're pescatarian, so steak chili, so. Steak chili. Yeah, it is, but like, she's pescatarian, so like.
Oh my god, so my dad.
Oh, weird.
Okay, here it is.
Like for like
Um,
animals.
And Sophia's right. If you look at number 5,
I'm not super serious.
and listen carefully, you could be given the question this way. A cup of coffee at 90 degrees Celsius is put into a 20 degrees Celsius room at T equals 0. Read the problem while I talk. The coffee's temperature is cooling at a rate of 7E, or changing at a rate of 7E to the, if you leave out that negative and then just say it's changing at a rate, you know if you have 90 degrees in a 20 degree room, it's gonna be cooling. So without that negative in front of the 7, we would have gotten 22 point something. Do y'all see what I mean? You're gonna have to notice things like this, and it's kind of good it happened on these 2 problems. I didn't expect this to happen. You've got to notice, if somebody says, a person is falling, a ball, let's not make a person, make a ball. A ball is falling at a rate of -5 feet per second, as opposed to they are falling at 5 feet per second. Do you see the difference? The velocity is still what? Negative, okay? So it is a good comparison in what's happening here. We know that water, as Grace said, is being pumped out, so there's no way sorry. What is 258?
It would be negative, you make it negative.
Right, so you've got to really read the problem and decipher and have an expectation of what's happening.
Isn't that like what we did with related rates?
It is, it's like related rates.
Yeah.
And so it's a really nice juxtaposition between the problems. It just didn't happen to us with number 5 because it came out what was expected. Hey girls, back to number 5. If they had said a cup of coffee is cooling at a rate of 7E to the negative, we would have gotten 22, but we know it's cooling, so we would have had to make it negative. Y'all see what I mean?
Yeah.
Okay, so maybe that's good that happened, because there's no way that I could have more water in the tank if they're pumping it out, so use common sense, okay? All right, now let's go to number 7 real quickly. Number 7. All right, number 7, we have these values. We have x, notice we have f prime of x, 0, 2, 4, 6. Always take great care to notice if those are the same in your Riemann sums, if those are the same width across. I think I just lost the whole thing. There it is. All right, these are all going by 2s. All right, and the rates here are 10, 18, 23, and 25. So we've learned a lot of lessons on this first page, how to read carefully, how to look at our graph, how to decipher what's happening, and using the fundamental theorem of calculus correctly. You want to write the whole thing out, okay? So now all of a sudden we're on Riemann sums because we're going to be estimating, if you underline the word estimate. All right, so we know f of 0 is 100, and they want me to find f of 2, I want to find f of 4, and I want to find f of 6. Do y'all see that? F of x. So if I want to find f of 2, if I want to find f of 2, I'm going to integrate this derivative from 0 because they gave it to me to 2 because I'm looking for it. And on this right hand side, what I've been stressing to you today
is I definitely want to go in and write that down. I think that's where some of you are getting lost. I know you definitely know how to do this. It's just you don't get lost. Be very literal. All right, now I can't work this out, but I can estimate it using a right-hand Riemann sum. Okay, and so I'm really just finding this. So back to review, right-hand Riemann sum. Right now, from 0 to 2, I only have one rectangle. Length times width. And so what they've given me here, I don't know what this looks like, but 0, 10 to 218. Do y'all see what's happening? So if I integrate that, I should be estimating this with a right-hand Riemann sum. So how wide is that rectangle? How wide is that rectangle? 2 units wide. And which height do I use? 18. So we're saying it's 2 by 18, and so we're using this as an estimate. Are y'all okay with that? All right, so I get 36 equals f of 2 minus f of 0 was 100. And so the answer for f of 2 is 136. So now how are we going to estimate f of 4? I'm going to take out 2 and put in what? 4. Now why am I starting back at 0? I want to use what they've given me, right? Yes. We also estimated f of 2. We don't want to use that anyway. Alright? Alright, so this is going to give me f of 4. Are y'all okay if I do it just erasing like this?
Yeah.
F of 4. Okay. Now, how many rectangles will I have from 0 to 4? 2 rectangles. If I go from 0 to 4, I'm going to have 2 rectangles. How wide is each rectangle? 2 units wide. And I'm using a right-hand Riemann sum, so I use 18. And then from 2 to 4, I use 23. And whatever that is plus 100 is the right answer. Okay? So what I want you to do for homework is finish this worksheet. So it gives you some stuff to really think about. There's some multiple choice later. I don't think it'll take you too long. It just took a long time for me to talk about it. That should give you a good start. Please check assignments. I'll set some bookwork that I don't know if I need to talk about before I give it to you. But before you start your homework, double check assignments. It'll be at least finish the worksheet and maybe 4 or 5 problems out of the book.
Thank you.
Bye.